Hi everyone, welcome to another video of Velotio Tech Shot. I am Prashant Kumar, currently working as a data engineer. I have expertise in Python, NumPy, Panda, DBT, AWS services, building ETL and ELT pipeline. In this video, I will discuss about data build tool. And the agenda of this video is I will discuss what is DBT, why DBT, DBT models, schema, DBT materialization, DBT Jinja, macro, UDF, and hooks, DBT snapshot, seed, test, and at the last, I will do some hands-on using DBT with Airflow. So, what is DBT? Data build tool is an open source tool used for transforming and loading data from source system into a target data warehouse. It is designed to work with data warehouses such as Snowflake, Redshift, and BigQuery. DBT helps automate the process of transforming raw data into format that is suitable for analysis by providing a set of tools and leverage for data modeling and testing, documentation, and collaboration. DBT allows data engineers and analysts to write SQL code to transform the data and provide framework for testing and organizing the transformation. This helps to ensure that the data is accurate, consistent, and available for analysis. Additionally, DBT provides a command line interface and web-based UI for managing the transformation and tracking the data lineage. Here I will discuss why DBT. So before implementing DBT in your project, you have to do following assumptions. Analytics warehouse runs on separate hardware. Data team has power to work independently from the engineers who focus on product development. The data team should have privilege to create the user, grant permission, and create object. DBT build transform data models in the same warehouse as your source data. A data should not move between warehouses in the process of data transformation. DBT uses SQL to transform the data. If your transform cannot be expressed in SQL, then you can also use Python. DBT is a batch processing tool. Idempotent means no matter how many times you run the model, it must result the same output. If these assumptions don't work for your project, then DBT may not be the right solution for your project. Like I will discuss about why DBT. DBT quickly and easily provide clean transform and data ready for analysis. Data build tool allows you to stabilize macros and integrate other function outside of SQL capabilities for advanced use cases. It automatically generates documentation around description, model dependency, model SQL, source, and test. DBT clouds include a feature that provides full autonomy with scheduling production refreshes at whatever cadence the business want. DBT provide automated testing. It comes pre-built unique, not null referential entity and accepted value testing. Additionally, you can write your own custom test using a combination of Jinja and SQL. Now I will discuss about DBT project models and schema. So DBT project file content important information that tells DBT how to operate on your project. And this is sample for DBT project.yaml file. I will discuss this later. DBT models. A model is a SQL query that defines a table or view in a data warehouse. Models are defined in individual files with a SQL extension, and they can reference other model views or table as input. DBT models are designed to be modular and composable. This means that analysis can reuse existing model and combine them in different ways to create new transformation. DBT allows include feature like testing and documentation generation to help ensure the quality and reliability of transformation. DBT basically suggests to write model in three directories, that is staging, intermediate, and MAD. We also call them bronze, silver, and gold. DBT models are defined in a YAML configuration file, which specifies the input, that is, which tables to use as source data, and outputs, which tables or view to create of each model. One of the main benefits of using DBT models is that they allow for easy testing and documentation of data transformation. DBT provides a suite of built-in test case that can be used to verify the correctness of data transformation. We can also write models in Python programming language. Now I will discuss about materialization. Materialization are strategies for persistent Materialization are a strategy for persisting DBT models in a warehouse. Materialization are four types, that is view, table, incremental, ephemeral. By default, DBT models are materialized as view. When using view materialization, your models is revealed as view on each run by create view as a statement. Pro of view materialization is that no additional data is stored, and view on top of source data will always have the latest record in them. And cons is that view are slow to query. When using table materialization, your model is revealed as table on each run by a create table statement. Pros of table materialization are that tables are fast to query, but the cons is that a table can take a long time to reveal, especially for complex transformation. Also, table require additional space to load the data. Incremental models allow DBT to insert or update records into a table since the last time that DBT was run. Pros of incremental model is that you can significantly reduce the build time by just transforming new records, and consider that incremental models require extra configuration. Ephemeral models are not directly built into the database. Instead, DBT will interpolate the code from this model into dependent model as a common table. In this slide, I will discuss about Jinja, macros, UDF, hooks. Jinja turned the project into a programming environment. You can recognize the Jinja based on delimiter expression, statement, and command. Macros are the piece of code that can reuse multiple times. DBT util is a powerful package that contains lot of common macros. UDF are user-defined function. You can use Python language to write UDF. Hooks are additional SQL statement and are four types: pre, post, on, start, run, on, and run. Pre and post should run at the start and end of your model, and on, start, run, on, and run hooks execute at the start and end of your project. Here I will discuss our DBT snapshot seed test. Snapshot monitor and manage the changes in records of data warehouse. There are two types of snapshot strategy. First one is timestamp strategy, and second is check strategy. Timestamp strategy are uses updated at column to determine if a row has changed. Meanwhile, check strategy work by comparing the list of columns between their present and historical values. Tests are assertion that you make about your project model and other resources. There are two types of tests. Singular test, it is simplest way of writing SQL that will return failed record. Generate test can be reused over and over again. DBT test can help you to catch bug in the data transformation pipeline. DBT expected is a Python DBT expected is a package which is around 100 useful test case. You can include them by installing the DBT expected package. Now I will do some hands-on using DBT with Airflow.
Here I will give you a quick walkthrough of the project Airflow DBT tab that I had created earlier. I will also share the GitHub link of this code so you can access it later. I'm using a Docker Compose file for the deployment purpose, and I also written some script to up the Airflow web server. Now coming to DBT directory. In this config profile.yaml file, I have added the credential of my Snowflake data warehouse. Also, I have created a project, Japelsoft. It is a very common project, present on DBT documentation website. So this DBT project.yaml file contains the information of this Japelsoft project. Inside the macro, I have written a macro name concat name. It will add the two first name and last name of a customer into single one. Inside the models, this schema.yaml file contains the schema of raw data tables. For example, this order table present inside the data like schema and having the columns like ID, user ID, order date, and status. Inside the staging directory, I have added three models: name, customer data, order data, and payment data. And this schema.yaml file contains the information of my these staging models. You can see here that I'm using some generic test case to check that first name of the customer data should not be null. This customer data model will store the customer table data as a view. Now coming to order data model. So here I am using incremental materialization and sorting the data on the basis of order date, and I'm fetching the data from order table present inside the data lake schema between a given time interval, and using this pre-hook statement I'm deleting the data between the given time interval before executing this model. Similarly, I have written a payment data model. It will fetch the data from the payment table present inside the payment info in schema. Inside the mark directory, I have created a model named customer model. So this model display all the information of completed orders. Here are the test cases. So in the test cases, I'm checking that there should be at least one record present in a table between a given time interval. So this is all about the DBT project. Now comes to the text directory. So inside the tags, I have written two Airflow tag. First one is DBT tag, customer DBT tag. So in this customer DBT tag, I'm executing customer data model. And similarly, inside the DBT tag, uh, I'm executing first order data and then payment data. And at the last, I'm executing customer order data model. And you can see that first, before executing any data model, I'm first checking that there should be at least one record present for a given time interval. So this is the code of my DEX. Also, I have deployed these DEX on a localhost server. So let's check it. I have deployed this code on localhost Airflow server. So let's check this out on a tab browser. This is the UI of Airflow, and you can see that both of the tags are present here and are in running state. This is all about the tag sort. I hope you like this video and find this video informative. Thank you.